So, in this video, we're going to take a look at how this rope climbing system works. First, you need a climbing animation. I have got mine from Mixamo along with its character from Mixamo.com. You will also need Unity's animation rigging package, which you find in the package manager. If I open up the package manager and you search for rig in Unity registry, you'll find this animation rigging package, which you need to install. So, if you're not familiar with Unity's animation rigging package, there's a link in the description that explains the basics. It'll make this tutorial much easier to follow. I also provide another link in the description that explains to you how Unity's new input system works. And one final note is that this video only covers the climbing mechanics. How you get your character into this position in the first place is also important, which is of course pretty easy, but we will cover it in the future videos if you find it interesting. So without further ado, let's take a look at the four fundamental parts of this system. First is the animation events. So you have this Mixamo animation. If you open up the actual asset, you can see you have this animation tab right here. If you click on it, you're going to see the climbing animation right here. And if you scroll down, you're going to see the events. These events help you know exactly which hand should release and grab a new point on the rope. Without them, you can't exactly tell when the IK targets should move toward the next position. You also need this animation reset event, which is at the beginning of the animation. This event helps you identify when the animation starts without extra coding. The second part is the animation controller. For this tutorial, the animation controller is pretty simple. It's just a simple state with that climbing animation inside. This animation, basically this state, is driven by a direction parameter, which determines which direction this animation should play. If it's positive, the character is going to move upwards. If it's negative, it's going to move downwards, like the reverse animation. And if it's zero, the animation is effectively on pause. Although for a realistic scenario, you need another animation for this idle mode. But that's not the purpose of this video. Then you have these three target points. Two of them are IK targets for left and right hands, and another point is the baseline target point, which basically determines how high the character is. So how they actually work, I'm going to cover them in a few seconds. The RopeIKContainer, which we have on our IK targets, controls the IK targets for the hands and moves them between rope nodes. If I select them and enable their mesh render, and also let me disable the actual character, you can see that what's happening here are two IK points that are moving up and down, and you have this baseline right over here, which determines how high the character is actually supposed to be. This is the general required setup for this climbing system to work. Now let's get deeper into how all these components are tied together. So first, let's see how the rope is set up. You basically have a list of nodes. These nodes are connected to each other with fixed joints. Basically, the connected body field of each joint is its previous node, and the very first node does not have anything connected to it. You see the connected body is empty right over here. Then we have these target points. Inside we have the IK target points and the baseline point. The way these 3 points work together is that the IK targets have this RopeIKContainer script attached to them, which is a script we have to write ourselves. I'm gonna show you the code in a few seconds. The RopeIKContainers have two functions in them: climb up and climb down. I have exposed them right here so you can see them in the inspector. These functions are triggered the moment the animation events, which I showed you earlier, are called. What they do is that every time they're called, they just move up or down to the next node segment of the rope. This is basically what you see right here. Let me disable the mesh render again. So whenever you climb down, it's just one trigger. Like every time the climb down is triggered, it just moves down, and every time the climb up is triggered, the IK targets move up. And we also have this rope baseline. There's nothing complicated about the baseline. It just takes the two targets, A and B. The targets are the IK targets. The calculation is simple. It finds the middle point of IK points and adds this offset to it. This rope baseline is linked to the root object using a position constraint. So if I click on the character root, you can see this position constraint I have here, and the source is rope baseline. So it will always follow the baseline position. So let's bring it back again. The IK targets are also attached to the arm bones, which you can see right here. I have the IK target for left hand and another IK target for the right hand. And I've set up the 2-bone IK constraint on each, which is basically the root, the forearm, and the right hand. I'm gonna select them all together. You can see them right here. This is basically this chain of bones. It's also important to see how this whole system is receiving player inputs. If I click on the character root, we have this player input component attached to the root object, and the move action from player map is triggering the on-input move of RopeClimber script right over here. The RopeClimber script is the main script that brings all of this system together. So in the next step, we're going to take a look at the codes of the scripts I just explained. So let's start with the RopeClimber. I'm going to open up in the editor. You see we have a reference to the left IK target and right IK target. The animator, the player input, and anything private you see here are used for internal calculations. So what is happening in the RopeClimber? We got to take a look at the on-input move. This is basically what we have linked to the Unity's input system. We use the player input for one thing, determine the direction of the animation. So if the direction is 0, meaning if the character is standing still, we're going to trigger the animation reset function. This function basically sets the direction and triggers the movement of the animation. This way of setting the direction parameter ensures that the animation continues moving until the animation reset event is triggered. This is the event I showed you earlier, which is triggered when the animation is in its starting point. This is where we also trigger it manually. Once that happens, we need to take a look at the update function. In the update function, what's actually happening is the calculation of this animation delta time. We need the animation delta time to know if the animation is playing forward or backward. If it's playing forward, it means the character is moving up. If it's going backward, it means the character is moving down. So why do we need to know that? We need to know the animation delta time to know whether we should continue climbing down or up. 4 events are also what we introduced in the animation events earlier. This is the main logic that ties everything together. Let's take a look at the baseline target. This is also nothing complicated. It just takes target A and B, finds the middle point, and adds the offset to it, which is for our baseline target. It's pretty simple. Then we have the RopeIKContainer. This is the script we attach to the IK targets. At first glance, it looks complicated. One reason that it seems complicated is that I wanted to have this kind of curve movement, like when the IK target moves to the next segment, I needed to follow a curved path instead of a straight line transition from one point to another. If you're not interested in that, you can only use this part of code in your late update, which will effectively make this function irrelevant, the Bezier point irrelevant, and this part also irrelevant. These private properties also become irrelevant. So what happens with this code as the RopeIKContainer, get back to the play mode, you can see the movement follow a straight line. Like if you look at the hands, you see they just follow a straight line compared to the previous one, which was following a curved path. But if you're interested in that kind of movement, we need to roll back to this script you see right here. One last thing to note is that you see these rope nodes, they have capsule colliders, and the character also has colliders attached to it, which will make these colliders naturally hit each other and cause the rope to have its physical natural movement, so you won't need extra coding for that. So that's pretty much all you need to know to implement this climbing system. So in future videos, we're going to cover how you get your character into this position in the first place, how you release them, how you jump between ropes, how you swing, and etc, etc. So thank you guys so much for watching. I hope you found this video helpful, and I'll see you in the next one.